How's everybody doing? Awesome. Hope you're all having an awesome conference. I'm Dan. Thank you for coming to my talk. Today I want to talk about something I'm really excited about, and the title of this talk is Clean and Green Pragmatic Architecture Patterns. And so now that we've kind of established where we are, the first thing I want to do is talk about why. And specifically, why from your perspective, right? Why in the world would you be interested in listening to me talk about this topic? And so I'm going to make an assumption that you build systems. And I'm going to be kind of hand-waving about what that means. A system could be, a small 10-line program. A system could be some web application or some data toolkit or, whatever. But I'm assuming that you're building something. And further, I'm going to assume that you would like to build systems that are understandable, right? That was
overrated.
Well, then maybe we should just go home. So I like to build understandable systems, right? I constantly have this feeling like, who wrote this code? And then I look and I'm like, oh, it was me. You'd like to build testable systems, right? So systems that are easy to test. You'd like to build maintainable system, and here's kind of the key selling point of this talk, is that maybe you're not actually building a new system. Maybe you're in the situation that I was in, which is that I've got this 7-year-old massive gnarly web application that was built without any reference to good software development principles. And here I am, and I'm like, I want to test this thing, and I don't know how. So that is what I want to talk about today. Is everything I'm going to show is going to work for if you're starting out with greenfield development, but I'm really going to try to emphasize the places where you do techniques that you can use for working on existing systems. So here we go. Why is this so challenging in practice? I mean, there's lots of reasons, right? But here's kind of my guess. When I look back at my software development education, there was a lot of emphasis on encapsulation, on information hiding. And let me go ahead and get this sidebar out of the way. I'm going to talk about a couple of different techniques that people use. I am not hating on any of this stuff, right? Encapsulation, perfect example. It's a very solid technique, right? But we learned that was sufficient, right? At least I did. That, okay, I have, what my job is as a software developer is to kind of provide this nice, clean, beautiful interface, and then whatever's going on inside, it doesn't matter, right? Or it doesn't matter that much. And so the question I want to raise is convenient callability enough? Is having a nice clean interface on the outside of our objects or subsystems or what have you, is that sufficient? And so I'm going to start with a simple example. And this is going to be a very heavy example-driven talk. Don't get scared when you see slides worth of code, because I will, anytime I do that, I will then break the code down and help you sort of walk through it. Or just tell you not to worry about it in one case, because it's horrible. But take an example, right? So let's say that we want to build some dashboard, right? Generic web dashboard, and we're going to use a web API to pull in some data, right? And in this particular case, I'm going to use Bitbucket because as I was writing this talk, that was what I was working on at work, and so that their API is kind of fresh in my head. But imagine that this, you swap out Bitbucket for some other service, and the pattern is basically the same. So here is my one of my data service providers that I might imagine. Let's say that my dashboard, I want to show pull requests that are for a given repository, right? So I want to collect, I've got a bunch of different projects, and I want to have one place that shows me, okay, here are all the open pull requests for my various projects. And so you could imagine building something like this, right? I get I have an identifier for the repository. Bitbucket, you actually have to pass both the owner and the repository slug, so that's the input, right? I take that and I format a URL for the API. I use requests. Request is awesome. If you don't use requests, go learn requests because it's amazing. I use requests, get the data, right? Get some big response object back, and then I just loop through the response and pull out the data that I need, right? Pretty straightforward. And hopefully this code is recognizable, even if your service is different or what have you, right? This is very standard sort of query a web API sort of code. And notice that the external interface is very convenient, right? I pass in these 2 bits of information that I need, and I get pull requests out. But inside that encapsulation envelope, we've got this coupled procedure, all right? And I've tagged it with these 2 comments about I/O. And so by coupled procedure, I mean that this procedure, and I'm calling it a procedure on purpose, right? This is not a function. It depends on something on the network, right? I have to make a call out to Bitbucket, get some information back, right? And that is buried in the middle of this procedure, all right? So you can sort of see it there. All right, why does that matter? All right, why does it make a difference? Yeah?
It makes it harder to test.
It matters because you want to build testable systems, right? Exactly. You want to build testable systems, and here is the sort of the crux of what I'm going to talk about today. That the issue here is complexity, right? That coupled procedures are inherently complex. Which makes them harder to understand and to test and to maintain, right? So let's walk through this. What are we actually trying to test here, right? I'll give you a hint. It's not Bitbucket, right? We don't care about whether Bitbucket works, right? If Bitbucket doesn't work, we're going to swap it out for something else. So our test suite, our local test suite, does not care about Bitbucket at all. What does our system care about, right? What are the pieces, what in this little teeny function, and again, this is a small example, and we'll work to bigger ones. What is it that our system actually is concerned about? Well, really, it's pretty simple. Given a response from the API, in other words, given some data, right? Basically, I want to make sure that I pull the right bits of the data out, right? So I have some, layout. Bitbuckets is actually kind of complicated. And so really what I want to know is that assuming that I get a response, a reasonable response, can I get the corresponding bits of data out of it? Oh, hi. And ideally what I want to do is to be able to test a bunch of different cases, test that logic on a bunch of different cases. What happens if I pass in an empty list? What happens if I pass in a list with a single pull request? What happens if I pass in none, right? What happens if I pass in a list of 100,000 pull requests, right? These are the cases. Sure, right? These are the things that I want to test, and the fact that this is an integrated procedure makes that harder. So in general, again, this is my first example, and I want you to keep in the front of your mind that this is an example, right? And sort of see how it kind of generalizes to work that you've done. So in general, the higher level question is, how can we build testable systems that have non-trivial dependencies? And by non-trivial dependencies, I'm really thinking about things like disk, web, database, what have you, right? And again, this is just a sampling of sort of the common ones. So, common approach is to fake it. Where faking it in this context means you build some sort of API-compatible replacement for your dependencies with test fixture support. Now, that reads sort of like right out of a textbook, right? Like, what in the world do you mean, Dan? Here's what I mean. So here's some examples of tools or techniques to do this. For general purpose stuff, we have mock, right? Mock is an awesome tool, and it can be used to create just sort of generic objects that you might want to work with. For more specific things, there are libraries that are built to kind of work with testing in a specific context. So for example, if you're building a web application in Python, chances are very good that you're using WSGI. And so web test provides all sorts of scaffolding to kind of take your WSGI app and wrap it in this thing that looks like a server, right? And provide these convenient ways for you to call in and see what response your endpoints are spitting out. For the other side of that, there's responses or HTTP pretty if you're doing like web client type stuff. These are and again, I'm just picking examples out here. Database. Okay, I burned like 18 months trying to do database driven testing. SQLite is a common approach that people use. You kind of build a mirror of your production database, but since it's SQLite, you can spin it up in memory and it goes away when you're done. Or you can do something like transaction wrappers, where you wrap each test in a transaction that's rolled back at the end. And so each test runs in kind of an isolated state. And then if you're doing like domain-based testing, you're testing something in your application domain, you might use something like mocks or stubs or doubles, all these different patterns that people have for testing things. Now, again, notice here that we've got all of this tooling built around this idea of faking some other dependency, right? All of this support. Unfortunately, it has problems. So one problem is that the calls are asymmetric, right? The way you work with these dependencies in your production code does not match the way you work with it in your test code. Here's an example. If I'm going to, let's say I'm going to use mock.patch to help me, so I'm not using responses, and I'm just going to roll my own, right? So I'm going to patch request.get so I can sort of shove my own data in for testing purposes. Well, notice that the production code and the test code don't look at all alike, right? I have this extra setup that I have to do just to make the test work. And this gets worse the more dependencies you add and the more complicated those dependencies are. This leads to kind of tricky, brittle, and awkward mechanics, right? And I find that it gets worse the larger the system gets, right? So examples for like patching or dependency injection look really nice when you're talking about a 10-line procedure, and they don't look so nice when you're talking about a 50,000-line system. Your mock is not the real library. Any of you done database testing with SQLite? Ever had the thing where you do that and then you switch over to like Postgres and stuff breaks because SQLite is not Postgres? They don't act the same way. They don't.
SQLite doesn't have types.
And or little unimportant things like, I don't know, alter statements, right? Like they're not there. So so this is definitely an arms race that you will lose, right? You cannot keep up with the upstream library. All of that, though, I think is symptomatic. The real issue is that faking it doesn't put design pressure on the complexity of your system. It allows you to build complexity into your system and leave it there, right? And I think that might be the root problem, that what we want is for our tests to change how we write our systems. In other words, testing informs your design. J.B. Rainsberger says it this way. He says the real benefit of isolated tests is that those tests put tremendous pressure on your design. They will force you to improve your designs. Uncle Bob Martin says it this way: testing forces us to decouple the software, since highly coupled software is more difficult to test. Right? So testing really should be primarily, I mean, yes, testing is designed to sort of give you confidence about correctness. Right? But at a higher level, testing should be informing how you're designing the system in the first place. So, is there an alternative? Well, this would be a very, very short talk if I didn't think there was. We could all go get cookies. But no, I do think there's an alternative, and that alternative is an architecture pattern that I learned about 9 months ago called the clean architecture. And so fake it, the idea of faking it, again, this sort of high-level definition, faking it is build an API-compatible replacement for your dependencies with some sort of test fixture support, whatever that looks like, right? Again, very, very sort of generic and hand-waving. But again, think of those examples, right? Mock. This is what all these libraries do. The clean architecture says something pretty different. It says separate policies from mechanisms. Policies from mechanisms, and pass simple data structures between the two. And so for the rest of this talk, I'm going to try to unpack that. What in the world does that mean? And also how. Right, I should mention that. This is a very pragmatic talk, because what happened to me was I went and I love software design and architecture and stuff like that, right? And so I went to these talks and I'm like, oh, this is so awesome, right? This is so cool. And then I went back home. I was like at a conference or something. I went back home and I sat down for work the next week, and I'm like, dude, I have no idea how to do this. And so my hope is that you will leave this talk sort of fast-forwarded from where I was, right? You'll go back to your code base and go, oh, okay, yeah, I see what he was talking about, and maybe I can start applying some of this stuff to make my systems better. So a few things I would love for you to walk away with. One, how do I recognize hidden complexity? Right? Because sometimes it's not easy. I've annotated the I/O in those things, right? But these are so far have been simple examples, right? When you're talking about an existing code base, it's not always so simple to say, where is this coupled? What patterns can I apply to remedy it? How can I build systems that I can change confidently? Another personal thing about me, right? I slow way, 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 way down when there's no test suite backing me up. Way down. Because what I spend my time doing is, instead of cutting code, I sit at my desk with my hands on my armrests thinking. And what am I thinking about? I'm trying to model in my head every possible code path that the change I'm about to try and make could affect. He's done it. He knows what I'm talking about. So, a lot of this is about freedom, right? It's about the freedom to change things and have an automated way of knowing, oh, crud, I broke this assumption downstream that I didn't remember because I can't remember that much. And then how do I organize larger systems? I'm going to argue that this scales from this simple toy example all the way up to entire systems. And so I'm going to try to give you some pointers about how to do that. All right, so let's go back to the example. Here is my my example. Again, bog standard API call, format the URL, get the data out, or get the data from the web, pull the data out. The first pattern is to promote I/O. And again, I mentioned that earlier that we were, that I at least learned in when I was, sort of a younger software developer, to encapsulate I/O, to wrap it, right, and sort of bury it inside of these encapsulated interfaces. I now believe that's exactly backward, right? That instead what you want to do, that the way you achieve decoupling of mechanism I/O from policy, the rules, is to promote I/O into what I'll call manager objects, right, that sort of collect and dispatch but don't make any decisions. So the I/O lives in this sort of thin procedural glue layer, and you have then it dispatches to the bits of your system that actually do the work. Or, as I like to put it, the reason your application exists in the first place. So that becomes something like this. In this example, we have it's basically the same structure, but notice that we've got a much higher level of abstraction, right? That it reads almost like a recipe, right? Build URL, get URL, extract data, and then extract the pull requests, right? And so all of the details about how that stuff works is put somewhere else, and that someplace else is in these functional helpers, right, that just work on data. And so build URL, takes an owner in a repository and formats a URL back. Piece of cake. Extract pull request is kind of more interesting, right? It's the thing that has to go through and work with the data and actually pull the data out. But notice, having done this, right, policies are clearly separated from mechanisms. These are the policies, the mechanism is the how, right? And notice that this no longer these two functions don't care that the data you're putting into them comes from Bitbucket. They have no idea. You just throw a blob of data at them and they give you a result back. Well, now, if that's the situation I'm in, right, testing is super easy because I can just throw data at the functions and it's not going to try to call Bitbucket. I can do this on the airplane, like the teeny little 90-seat plane I was on that had no go-go and no air conditioning either. I could test there, right? I could run these tests on that in that environment and they would work. If you want more about why this is, there's lots of reasons that this is awesome. I'll plug another talk, another guy who talks about this stuff, Gary Bernhardt. One of his big things is efficiency, right? These tests run lightning fast. And he shows some really cool demos where he's running like 200 and 300 suite tests in a couple of milliseconds, right? And that provides a much faster feedback cycle. Again, if you're interested in working efficiency, that's definitely an interesting direction to explore. Anyway, so by improving the testability of this code, we've also improved its design, right? It's better separated. We've got better separation between the things that we care about, the logical bits, and then the glue code that kind of makes those logic bits work. So that was my first example. Here's the second. This was a problem I stumbled on recently. Given a root path in a file system, return a list of sets where each set has all the paths that have identical contents. All right? Here's the idea. You pass it, home photos, and it gives out a list. And we've got a.jpg because it's the only file with that content. But notice I've got b.jpg and copy of b.jpg that we're sort of pretending are just copies of each other, right? So that's what this problem is, right? You're given this path. Produce a list like this where you identify, whenever something's been copied in the file system, you identify all the places that that the same content exists. Here's my first attempt. Basically what I'm going to do is build a mapping from file hashes to sets of paths, right? And I'm going to sort of build that up, but then I'm going to throw the keys away because I don't really care about them once I'm done. So I set up my empty data structure. I go through and find all the files. I hash their contents and add them to this data structure, and then just return the values. Because again, the values are this. When you call .values, you get exactly that output. Locate files is just a simple, teeny thin wrapper around the standard library routine os.walk. Basically, instead of having to iterate through the subdirectories, it sort of smooths that out, just spits out a list of files. So it's like totally simple. And hash contents, let's say that it computes the SHA-256 of the file's contents, right? And again, it's easy to do this in the standard library. So again, how would you test this? Right? We've got two I/O calls, two coupled dependencies buried right in the middle of this thing. And locate file and hash contents depend on the state of the disk, which means that your tests depend on the state of the disk or on the energy that you're willing to expend simulating that state. So, for those of you who like pain, let's take a very short walk down the path of destruction. You might think, let me do something like this. Well, I could create this temporary file tree and like stuff some data into it. And so I have this horrible context manager that I write, and somehow magically I know what the expected output is, and I pass that temporary route to this. Now, obviously, this is absurd. And it's absurd because this is totally not simple, right? And here's the thing. You're going to need these one of these context managers is not going to be enough, right? You're going to need a context manager for entire classes of things that you want to test. Like every edge case is going to have its own context manager. You're going to spend all your time writing context managers for your test suite, right? And as J.B. Rainsberger points out, you'll do that for 2 weeks and then you'll give up. Right? It doesn't work.
Just check these into your repository.
Yep, we're done here, folks. Oh, that's amazing. Little sidebar, I checked in like a 60 megabyte JavaScript library the other day, and now my DevOps guy hates me, and I feel really bad. So yeah, let's not do that. How many test cases will you have the energy to write this way, right? I mean, again, you'll do this, as he puts it, you'll do it for 2 weeks, and then you'll be in production code. It's going to be slow, it's going to be inefficient, but again, what I want you to focus on, right? What do we actually care about here? We don't care about the state of the disk. We're going to assume that os.walk actually works, right? We assume that fileopen.read actually works, that SHA-256.digest, that these functions, or routines that are built into the library actually do their job correctly. And if these routines don't work, then we have a bad programming language, not just a bad library, right? I mean, maybe we go home and like dig ditches or something, because the world is just done. So, if we subtract these assumptions out, right? Imagine, just minusing them out, right? What we actually care about is that if I've got two strings that have the same hash value attached to them, they should end up in the same bucket. That's the rule. That's the policy. The other bits are just mechanism. So for testing, coupling's a distraction, right? It's getting in our way. So how do we fix it? The first thing we can do is apply the first pattern, promote I/O. There's I/O in here that we can easily promote. Anybody got a guess as to what it is before I advance? Bingo. Pass in a list of files instead of a root path. Right? Totally obvious thing to do when you're first looking at it is to say, well, let's make an level of indirection between the thing that gets the root and the thing that gets the files, right? So I've decoupled those two bits. Great. Problem. How do I get rid of hash contents? That one is not going to come out quite so easily. So the way that we get rid of it is through applying the second pattern, which is to think of your system in terms of data and transformations on that data. Data and transformations on that data. The reason is that data and transforms are easier to understand than coupled procedures. That it's easier to understand. This is why the Unix pipeline idea is so powerful, because it's very easy to reason about. I have these steps, and each one is surfacing data. At any point, I can break the pipeline and see what the result is. I can reassemble the bits if I need to. I can, take a bit out of the middle, put a new bit in. That sort of flexibility is easier for us to understand than giant object graphs. So how would we express this as a transformation of data? The way you do it is to recast the logic part to work on what I'll call an annotated transform of the data. Well, what do you mean by that? It's kind of, when you see it, you'll be like, well, duh. It's simply this, right? Notice hash paths in the middle. It takes in a list of paths and gives you back another list of paths, except that each path has had the hash value attached to it, right? So I take one list, I transform it into a second list. The paths with same hash now, the transform then produces these simple data values, right? It's still coupled to the I/O because hash, whatever I called it, contents, does actually touch the disk. But the policy function is just that. It's a pure function, right? It expects to get a list of two tuples. Hash path. And it actually doesn't even care what the two things are, right? All it's going to do is put all the things with the same A value, all the B's with the same A value into the same bucket. Well, that sounds a lot like what our policy was when we sort of unpacked it earlier. And again, these policies are easily testable with simple data, right? You construct a simple list to handle all your cases, and you check that the output result matches what you expect. These will run lightning fast. You don't need any test scaffolding. It's just Python, right? And they're easy to understand and easy to reason about. All right, third example. How's everybody doing? Cool. The third example is from my application domain. So I work in the candidate and credential management space. And so one of the questions that we ask is, okay, a candidate wants to apply to take a test, an exam. Have they reached the limit? Some clients ask us to say, well, and a candidate can only take this particular exam so many times, and then you're out, right? And so if this is configured, how do we do it? Oh, don't look at that. Okay, I'm going to show you some really horrible code. And actually, I'm only going to show you about a quarter of this method. Don't try to read it. You'll burn. Your eyes will burn. So just grok the overall structure, and we'll sort of talk about what's going on here. All right. So again, there's like 40 or so lines in that first comment. There's another 20 in that second one, and then there's a whole bunch of stuff that I'm showing off the screen. Danger, 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 danger. How in the world is anybody going to understand this, right?
Documentation.
You're funny. The source code's the documentation, man. Yeah, no, there's no documentation. Are you kidding? This is an enormous method. Again, this excerpt is about a quarter of it. Notice I think it's like 6 layers deep, 6 levels of nesting deep. And the bit that I'm actually working on here has nothing to do with the method name, which is get available sections, or I guess it's a procedure. What in the world does that code have it doesn't actually have anything to do with it. So what I want to do is tackle just a piece of it, the bit that handles failed dates. What we're trying to do here is figure out how many times has the candidate already failed this test, right? Not super complicated. But unfortunately, the handling of that is very obscure because it's very spread out. So here is that same code, except that I've deleted all the lines that don't have anything to do with fail dates. I say again, I deleted all the lines that don't have anything to do with fail dates. Well, wait a minute. We've got some input data, right, that we're looping over, and then we apply not 1, not 2, not 3, but 4 transforms to that data, but we do it over the course of about 30 lines, right? We check to see if the candidate withdrew an application, it doesn't count, so we discard those. We check to see if the exam I'm asking about, the application is for a different exam than the one I'm asking about. We don't need to see those. We extract the exam date from whatever's left, and we sort the result. So 4 transforms, but applied over the course of, here, let me show it to you again, right? 1, 2, 3, 4. And again, over the course of 25 or 30 lines of code, this transform is being carried out. Needless to say, this is quite obscure and cryptic. And I've made it easier for you. It's actually much harder to understand in its native setting. So pipeline, the idea with a pipeline is, remember that pattern 2 idea, the data and transforms thing? You just do that in steps. You take 2 of those and you munge them together. So you just do it twice. Right? Not super complicated. So here is how I might write a pipeline to do that same procedure that we just saw. All right. So first, what's that? Yeah, I think in the actual implementation I do. So filter out withdrawn applications is just a simple function that does the withdraw check, right? Filter out the of type filter. So I'm writing a second filter that filters out applications based on a specific exam type. Notice how much easier that is to understand. And then you just connect the pipeline up. Sorted is built in, right? So I don't have to build that one. And the extract the app date, I thought about like making that a separate function, but decided not to, right? Just for giggles. There's the pipeline. Notice how readable it is, right? I need the applications that haven't been withdrawn of a particular type. Please extract the date from those and sort them. And the cool thing about the pipeline is that it allows a complex transform to be expressed as a series of simple transforms, and those bits can be pulled apart, put into other pipelines. They're easily tested and convenient to reuse. So far, what I've argued is that I've sort of set the stage. You want to build or transform existing systems such that those systems are easy to understand, easy to test, and easy to maintain. We've looked at sort of faking it, but again, I'm trying to make the case that instead, try building your systems around this idea of functional transforms of simple values and data structures. And so now I want to take a little bit of a detour and talk about some potential objections, right? And one objection I'm not going to talk about is the Lisp folks and all those pure functional people who are like, we've been saying this for 50 years or 60 years or whatever it is. Yeah, I know. I wasn't there for that. The objections I want to look at are a little bit more that are a little bit more what I've encountered. Nobody argues that pure functions aren't testable, right? Nobody argues that they're not expressive. So what's the problem, right? The arguments basically fall into sort of 2 sets. Well, that's neat, That's pretty. You can't build a real system with that. We can't afford to rewrite our whole system. It's the second objection. I don't think these concerns are actually valid. First off, do not do a full rewrite. And if you want to read about why, go look up Netscape 4. They tried it, and it was a disaster. And there's actually some really cool documentation about all the ways that that project just died. But it was terrible. They tried to do the big rewrite, and it was a disaster. Don't do that. Don't do that. But you don't need to either. You can build real systems this way. And we're going to try to leverage the Zen of Python. Simple is better than complex. How do you do this? This is the clean architecture. What I've been talking to you about so far is, in microcosm, what the clean architecture does for large applications. This is the scary diagram that you'll see if you go out on the web and look up clean architecture. Basically, the idea is fairly straightforward. That, as I've shown in the first couple of examples, right, instead of putting burying the I/O in the middle, the idea is, nope, flip that around and put the dependencies on the outside, right? And so in this diagram, you've got like the mechanisms, the particular web framework you're using, the particular database engine you're using. And on the inside, the yellow and red circles are the policies. Again, the reason you're writing your app at all. In general, the further in you go, the higher level the software becomes. The outer circles are mechanisms, the inner circles are policies. The important thing is that isolated, simple data structures are passed across the boundaries. This is the key. I had somebody come up to me and argue that, well, wait a minute, we can do this with an n-tier architecture. And we sort of talked about that for a minute, and then I realized, yeah, you can do this. If you want to use an n-tier architecture, you can do the same thing, right? It's kind of just a different layering. But the key is to pass these simple data structures across the boundaries, because that's going to give you that decoupling, right? If you're passing some ORM object across the boundary, then you're passing not just this one object, but this entire object graph, right, of all the state, of all the things that that object depends on that are hidden from you by the ORM. So the key is that the layering between the systems needs to work regardless of whether it needs to work with the assumption that I'm just getting data. And here's kind of the payoff. When any of the external parts of the system become obsolete, you can replace them, right? And Lars showed a great example of this in his talk about how it was very easy, because these systems were connected using very loose connections. It was easy to just take one piece out and put another piece in. Cue R2D2. So, pragmatic architecture patterns, tools for applying the clean architecture to existing systems and new work. Here's the ones that we've seen so far. How do you organize bigger systems this way? I've got one sort of bigger example for you. And again, this is from the system that I work on. This code is dealing with end-user license agreements. Right? So our clients say, well, we want our users to, when they sign up, they need to agree to this legal agreement because our lawyers say they have to. Great. And so this is kind of a management thing for that. So this is the delete endpoint for an end-user agreement. And there are a couple of rules, right? If the, right? So how it works. First, we fetch you give me an ID, I fetch the corresponding agreement out of the ORM. So get it out of the database. Check that it's not yet active, and format a message back if it is. So I can't delete an active agreement, and I can't delete the only agreement that's in the system. when you delete an agreement, we need gap coverage. So we need to adjust the dates. Hey, everybody. We need to adjust the dates in order to make sure that that gap is covered, right? So if there's any gap between the agreements that's left by the hole that you just deleted, or that you just created, we need to fix it. And then actually do the delete. How would you test this? By my count, there are, depending on which code path you take, 5 or 6 ORM calls. There are 3 business rules, which isn't such a big deal, except that there are also 5 axes of responsibility here, right? This is it's not very much code, and actually this is not edited, right? Well, it's a teeny bit edited because I didn't want to put the whole comment in there, right? But the actual code looks exactly like this. Awesome. Fast forward. Thank you all very much.